Hi folks, welcome to lesson 1.4 in the third video. I wanted to make this video separate because the last video, it was fairly detailed and took a long time, so I wanted you to take a little break and do a couple of questions with cylinders and of different sizes before we move on to this one. So this one is another compound or composite object, and it is basically it's a porch, and we need to paint it. So we got to consider, it's a real life object, we have to consider what we need to paint. We need to paint, okay, everything that, is orange. So we got to paint this side, the side we can't see. We've got to paint the front of this. We've probably got to paint the bottom of this, that's part that's underneath. We've got to paint the outsides of these two cylinders, those columns, and we've also got to paint the top and sides of this piece here at the very bottom. What I think we don't have to paint is we don't have to paint underneath this. We don't have to paint the part that hits the ground. We don't have to paint the part of this top part that hits the house, okay? We don't have to paint the back part of this little rectangular part at the bottom because it hits the house. We don't have to paint the top, the circular parts of the cylinders because they just basically go into the roof and into the ground. So there's some stuff here that we don't have to paint, so let's not make it harder on ourselves by subtracting those things later. As always, we should separate this into separate objects, okay? I'm going to count this top part as number 1. I'm going to count both of the columns as number 2, so we'll do them together. And then I'm going to count this base part as number 3. Always one thing at a time, okay? If you try to do this all with one huge convoluted formula, you're going to get very frustrated and it's going to, you're going to make mistakes. It's just the way it is. So I notice here that this kind of got cut off. That's going to be 2.0 meters, so sorry about that. Of course, I covered this up. That's 2.2 meters. All right, so I've got 2 meters, 2.2 meters, 15 centimeters, and the rest are in meters. Okay, let's take this and convert that to meters, so everything we're doing is meters. So you just divide by 10 to get to, divide by 100 to get to meters there, so that's 0.15 meters. Now everything's in meters, and we're in good shape. Let's start with number 1. What do we need to paint? We need to paint the front, the underside, this side, and this side. We do not have to paint the back, so let's just start with the front. It is a triangle, and this is what it says about the triangle. It says that this means that this is an equilateral triangle. All 3 sides are exactly the same. Okay, all 3 sides are exactly the same. Does that help us? Yes, but we still have to do a little bit of math, okay? So I'm just going to take this triangle over here, and what I'm going to do is I'm going to redraw it to show you how we get to what we need. So this is a triangle, okay? This is a triangle, and we know a couple things. We know that this is 2, this is 2, and this is 2. But what we need to do the area of a triangle is height. So how do we find the height of a triangle when we're giving something like this? Well, what we do is we kind of have to create it. So what you're going to do is you're going to draw a straight line, and you're going to do a much better job of it than I did there. You're going to do a straight line to split this thing in half. Okay, and we can use that. So this part here is 2. Now I'm just going to draw a straight line instead of the one I just drew before. There we go, that's a little better. We're going to draw a straight line right down the center of the triangle to cut it in half, which makes this part here 1 and this part here 1, because this is exactly half if you draw a line straight down. Also, that's a right triangle. Okay, so I'm going to draw a little arrow that points to the C value. Okay, so we got to do a little extra work for this one, right? What we don't know is this part right here. We don't know what that is, and that is the important part because that's the height. We're going to figure it out. Okay, so I'm just going to put up here finding height, or h. Okay, let's find h by using Pythagoras. All right, a squared plus b squared equals c squared. A can be either this one or the height. I'm going to make this one a. This has to be c, and then this is going to be the b. So a is going to be 1 squared plus b squared. We don't know what that is. That's going to be the height. Equals c squared, which is 2 squared. So 1 squared is 1. We don't know what b is, so we just got to say b squared. And 2 squared is 4. We got to keep the b squared here. We got to get all the numbers on the other side. So b squared equals, Okay, got to subtract 1 from both sides. B squared equals 3. Now we've got to square root both sides. We've done this before, so I'm doing it kind of quickly. Doing the square root cancels out the square, so that leaves us with b, which is exactly what we want. And then we want the square root of 3, which is 1.73 and a bunch of decimals. Okay, unless I tell you otherwise, just use a reasonable amount of decimals. So in this case, let's just do 1.73 meters. Okay, so it took some work, but this is the height, okay? This is the height of the triangle, which we need in order to do area. So that for this front part here, we have a triangle, okay? We have a triangle, and it's going to be half of base times height, so, or BH over 2. We know what those are now. The base is, what's the base? 2. 2, okay? Because the base is this whole measurement right here, okay? So from there to there, and we know that's 2. So the base is 2, the height we figured is 1.73, and then the number 2 is just the number 2, right? So let's figure that out. 2 times 1.73, and then divide that by 2, and I get, well, why am I even doing math? Silly Dunbar. It's multiplication and division. I got a 2 up top, I got a 2 on the bottom, which means I just cancel them out. The answer is 1.73 meters squared. So that takes care of this whole front part. And we don't have to do the back part because it's attached to the house. So it was a lot of work, but we finally got that first chunk done. Now we've got 3 rectangles that we have to consider. The one here, the one on the other side, and the one on the bottom. Well, because this measurement here is the same as this measurement here, and it's the same as this measurement here, luckily for us, that means that all of these 3 rectangles are exactly the same. All right, so I'm just going to do, instead of the front, I'm just going to say rectangles. And they're all the same, thankfully for us. So the measurement for those rectangles, okay, is going to be 3 of them, right? 3 rectangles, and then it's just length times width. The length is 2.2 meters, and the width is 2 meters. They're all the same. So they're not always going to be the same, all going to be the same, but in this case they were, which is very handy for us. So 3 times 2.2 times 2 equals 13.2. So that is 13.2 meters squared. So we've taken care of the front, we've taken care of the bottom, we've taken care of this side, and we've taken care of this side. There is one thing that I didn't consider when I did this part, and that is, look at that column and that column. They hit that bottom rectangle. So we actually have to subtract a little bit to take care of that, because we don't have to paint the areas where those columns hit the bottom rectangle. So I'm actually going to have to subtract a little bit from here. I'll just call that overlap. Okay, and the overlap is going to be 2 times whatever that is right there. Do I know what the radius of this pole is? Do I know that? This is missing information. You need to know either the radius or the diameter of these poles in order to figure it out, and we don't have it. Oh, sure we do. 20 centimeters, right there. There you go. It's important to read the entire question, I guess, eh? So the radius, okay, I'm just going to put radius equals 20 centimeters, but we're working in meters, so the radius equals 0.2 meters. Okay, so we do have enough information to solve this. We need the area of one of these circles at the top. Area of a circle is pi r squared, okay? So we need to subtract 2 of them, so the overlap is going to be pi r squared, okay, which means it's going to be 2 times 3.14, okay, times radius, which is 0.2 squared. All right, we always have to do the squared part, or the exponent first, because that's just the rules of math, bed maths. So that's 3.14 times 0.2 squared is actually 0.04. Okay, put it on your calculator if if you don't believe me. So the math we do here is we just need to do it all together, right? 2 times 3.14 times 0.04, because it's multiplication, and we get 0.2512. I'm just going to make that 0.25. That's probably enough centimeters squared. So this is the overlap from the cylinder that hits this, and there's two of them. That's why I put the 2 in there. So our total, see, our total surface area for number 1 is 1.73, okay, plus 13.2, and then let's just subtract 0.25 to take care of those little overlaps from the columns. So if I do this math, 1.73 plus 13.2 equals minus 0.25. I get 14, okay, I get 14.68 meters squared. We took care of number 1. Number 2, okay, I'll draw a little wavy line there. Here's number 2. What is number 2? Oh, it's our 2 cylinders. Now these are going to be easy because we don't need to care about the circle at the top and the circle at the bottom for either of these because they are attached to the top and bottom of the porch. So we just need to worry about the rectangles on the outside. So there's 2 rectangles, okay? So whatever we're going to do, the surface area is going to be 2 times. When we unfold these, okay, the height it's going to be, the height is given, I think it's 2.5 meters, so that's the height, okay? We need to do the circumference of the circle, so that's 2 pi r, okay? And then we have to multiply that by the height. So we know all these things, we just have to put them in. Okay, so 2 is a 2, good. Another 2 is a 2. Pi is 3.14, we always know that. The radius is, what did we say? Radius is 20 centimeters, so that's 0.2. Okay, so we know that as well. That's 0.2 meters. And then the last part is the height, which it was, I believe, 2.5 meters. So we've got all the information. We just need to do the math. And it's all multiplication, so we can just do it all in one big 2 times 3.14 times 0.2 times 2.5. We can do it all at once, and we get 6.28. 6.28 meters squared. And that takes care of the wraparound part of both of these cylinders because we don't care about the top circles or the bottom circles. So number 2 is actually pretty easy. We got that one. We got that one done super quickly. All right, number 3. Let's look at again what we need to paint. So for number 3, we've got a couple things we need to consider. We don't need to paint the bottom because that's the ground. We don't need to paint the back of this because that's hitting the house. And we don't need to paint the 2 areas where these circles hit because they're overlaps. So we do have to figure out a bit of an overlap, just like we did with the triangular portion on top, but the rest should be pretty simple. Okay, so let's look at the front. We need to do the front. That's 2 meters. So that's just length, this little part here, little shaded part. Okay, we only need the front, we don't need the back. So the front's going to be 2 meters times 0.15 meters, because that's how tall it is. Okay, so we'll just do the front equals, what did I say now? Of course I forgot. It's length width, right? And the length was 2 meters, and the width was 0.15, I believe. So that is just going to be 0.3 meters squared. That was easy. So that's the front. Okay, let's do the 2 sides. The 2 sides are the same, and we have to paint them both, and they are 2.2 times 1.5. Okay, so this is, next part's going to be right side, left side, and that was 2.2 meters times 0.15. So 2.2 times 0.15 is 0.33. Okay, so 0.33 meters squared. That was pretty easy. So we took care of the front. We took care of this side and the other side. Now the only thing left to do is this top part, and we're going to have to subtract the overlaps. So I might actually do that. Down here just to give myself a bit more room. Okay, so what is the top measurement? If it was just, we were going to do the full top of this thing, it would be 2 meters long by 2.2 meters wide. Okay, so this is going to be, what are we going to call this? We're going to call this the top. is going to be 2.2 meters times 2 meters. So that was length times width. And that's going to give us 4.4 meters squared. But there's overlaps. Okay? And the overlaps are exactly the same as they were before, right? Because the overlaps, we've already figured out. There were 2 of them on the rectangle here at the bottom of feature number 1, and there's the exact same 2 on the top part of feature number 3. So we already figured that out, that the overlap is going to be 0.25 centimeters squared. Why do more math? Okay, the overlaps are 0.25 meters squared. So our total, okay, so number 3 surface area equals, add them all together and then subtract the last part, right? 0.3 plus 0.33 for the sides plus 4. Oh, haha, quick mistake. Glad I looked. Glad I looked. Okay, right side, left side. There's 2 of them. I have to multiply this by 2. Otherwise, I'm only taking care of either the right side or the left side. So I'm just going to sneak a 2 in there. Okay, I'm going to sneak a 2 in there. And then it's actually 0.66 meters squared. Glad I looked. 0.66 meters squared plus the 4.4 meters squared we had at the top. And then at the very end, let's subtract that little overlap. And then that should give us our answer. So I can just do this in order for bed mass. 0.3 plus 0.66 plus 4.4 equals, and then I can subtract the 0.25, and what I get is 5.11 meters squared. Not quite done. All right, now the last thing we need to do is add up all the stuff that needs to be painted for all 3 shapes. So total painted area. You can just write area on yours or surface area. I just want everyone to know what the final answer is referring to here. Surface area of number 1 is 14.68. So, okay, so it's going to be 14.68. That's the stuff we need to paint on the very top. Then we've got to paint 6.28 for the cylinder parts, and then we've got to paint 5.11 for the bottom part. So we add all those together. 14.68 plus 6.28 plus 5.11, and we get a grand total of 26.07 meters squared. Now the original question, always make sure you go back and answer the original question. What is the area to be painted to the nearest square meter? Let's look at what we got. Nearest square meter? Okay, well these are the meters, that's a tenth, and that's a hundredth. So our final rounding is, we need, we're going to round it, well, 0 rounds to 0, right? Because we're not rounding it to 1 decimal place, we're just rounding it to the nearest square meters. So we need 26 meters squared of paint. So always go back and do that last, read over your question, make sure you're answering. Hey, again, I know this can be a little daunting. Look at all the math we did. We did so much math. But I tried to keep it really organized, shape by shape, and then within each shape, side by side. And if you take your time, work your way down, you'll be less likely to make mistakes. It's not mistake proof, as I proved up here by forgetting I had to multiply this by 2. But if I'm going back and reviewing, or if I get the wrong answer, and I can tell from the textbook, or if Mr. Dunbar says, this is the answer, is that what you got? You can go back and track through piece by piece and easily find where you made the mistake. If I had let that mistake stand, and somebody had emailed me and said, that's not the right number, that's not the number I came up with, I could easily track through this, and eventually I would have hit this point and gone, I forgot to multiply that by 2. So hopefully that should help you with most of the really complex objects. This is the same object, I just wrote it down twice for some reason. So hopefully that will give you enough information to solve some of these more complex composite objects. Best of luck. Let me know if you have questions or concerns.